Okay. I'm trying a new format for my notes. So I typically date them first, but I'm trying something different. So you can date your stuff. I think it's a great idea that you do start each new set of notes off with the date, but I'm going to be using this section that I'm working out of, chapter and section that I'm working out of, to be titling my notes now, slopes of lines. And also, I'm going to try to condense everything to focus, meaning instead of you having to go to YouTube to find notes, I'm going to start posting the link on Focus by date. A little bit louder, please. Well, it'll just link you. Yes, it'll still be there, but they won't. I don't think I'm going to title them on YouTube by date anymore. But if you just go to Focus and you go under the Resources tab, that's where you're going to find the notes. And it's just going to be a click, and it'll link you to YouTube, and it'll be there. Okay? So if you didn't hear that, I'll write it. Links to the notes. Links to, we'll say links to the notes from class will be posted to Focus under Resources. That's where the study guides currently sit. That's where the quizzes sit. So now the notes will be there. And I think next week we're going to phase out the workbooks. And if you're a in-class person, you'll get a handout on Monday that will have the practice problems for the week. If you're an e-learner, it'll be posted. Those same pages will be posted under the Resources tab. So what I'm trying to do, since this is my favorite class, I'm trying for you to have to just go to one place for everything. All right? And it can be electronic if you want. You don't have to you don't have to have a workbook. All right? You'll be able to see the questions and access those from your phone or electronically or however you want to. You can also still print it if you want. If you're in class, you'll get a printed copy on Monday or Tuesday of each week. Everybody all right with that? Good, good. All right, so slopes of lines. The slope of a line. Is the ratio of the change along the y-axis to the change along the x-axis. All right, so the letter M is used to reference slope. So the slope formula looks like M, where slope is equal to your change in y values, so it's your y sub 2 minus your y sub 1 divided by your x sub 2 minus your x sub 1. That's your change in y values divided by your change in x values. It's also the same as rise over run. Rise over run. All right, so today you're going to be finding slopes of lines to begin with. We're going to find the slope. And then you're going to be given a line and the line will have points on it. So let's say that one point is located at -1, -2. And the other point is located at 3, 3. All right, now if it's sitting on the coordinate plane and all the coordinates are whole numbers, your slope is going to be equal to, I still like, I don't know, until you get real good at this, here's my x sub 1 and my y sub 1, my x sub 2 and my y sub 2, and then substitute the values into the slope formula. So we go 3 minus -2 divided by 3 minus -1. You got to be careful when you've got negative values. And remember that the formula calls for the difference in the values. And remember that when you're subtracting a negative, it's the same as addition. So 3 minus -2 is the same as 3 plus 2. And 3 minus -1 is the same as 3 plus 1. All right? So we get a 5 in the numerator and a 4 in the denominator. So the slope of this line is 5/4. Rise over run. The other way you can look at this is you can say that if I go to the lowest point on the line and then I go vertical like we did last week when we did the Pythagorean theorem, if I go vertical, I'm going from -2 to 3. From -2 to 3 is 5 units. And then if I move horizontal till I hit the line again, or the second point on the line, I created a 90-degree angle. I went from -1 to 3, so my horizontal change was 4. All right, so my rise over run is 5/4 as well. So there's two ways to do it. You can use the formula, or you can get on the coordinate plane and count rise over run. Sometimes you'll be given your coordinates. You won't be given the coordinate plane. You'll be given them as an ordered pair. So maybe you get 6, -2, and -3, -5. And again, you're asked to find the slope. And especially in this case, I would highly recommend that you label. So here's x sub 1 and y sub 1, x sub 2 and y sub 2. Slope is equal to, in this case, we got -5 minus -2 in your numerator. In the denominator, -3 minus 6. We're going to keep change. So -5 plus 2 is -3. And -3 minus 6, -9. And what's a negative divided by a negative equal to? That's a positive. So we got to simplify this, right? So -3 divided by -9 becomes a positive 1/3. All right, so there's your slope of that line. Positive 1/3. Let's take a look at some slopes for different looking lines. All right, positive sloped lines. If a line has a positive slope, then it moves up and to the right. Negative slope lines. Negative slope lines, those go up and to the left. Lines with a slope of 0. Zero slope lines, those are horizontal. And then we have undefined. Undefined slope, and what's the only line we got left? Good, vertical lines. If you have your calculator out, sometimes people have a hard time remembering horizontal is a 0 slope, vertical is an undefined slope. What's the rise? If I'm at a point on this horizontal line right here, point A, and I've got point B over here, and I put my pencil on point A, what's my rise to get to point B? It's 0, isn't it? So my rise is 0. And I've got to run, don't I? I've got to run. I've got a number. I'm going to just call it 6. If you go in your calculator and you type 0 divided by 6, you're going to get a value. And that value is 0. There's your 0 slope. 0 rise means 0 slope. 0 rise means 0 slope. On this vertical line, if we go to the bottom of the line and we put our pencil on point A, we've got rise, don't we? We've got a value for rise. Let's say it's 6. But if I rise 6, how much do I run to get to point B? I have 0 run, right? So I got 0 run. And if you type 6 divided by 0 in your calculator, it says error, doesn't it? Well, error means undefined. Okay? Error means undefined. Zero rise is zero slope. Zero rise is zero slope. And if you can't remember which one is which, just type it in the calculator, rise over run. You know that slope is rise over run. So if you type a 0 over a 6, it's going to tell you the slope is 0. If you type 6 divided by 0 and you get error, error is the same as undefined. All right, let's kind of go back up here for a second, and we should have up here, the slope of a line is the ratio of the change along the y-axis to the change along the x-axis. The letter M is used to reference slope of a line. We're going to say that slope can also be referred to as rate of change. And I bring that up because you could be given a problem and asked to find the rate of change. If you're asked to find the rate of change for a set of data, they're just asking you to find the slope of a line that the data represents. All right, so slope and rate of change, they mean the same thing. Slope and rate of change mean the same things. All right, next we're going to say here that you can use the slopes of two lines to determine whether the lines are parallel or perpendicular. And we talked a bunch yesterday about parallel and perpendicular lines and them being cut by a transversal and different angle rules. So we're going to say here that parallel lines okay, those have the same slope. Parallel lines that have the same slope. Okay, if A is parallel to B, then their slopes are congruent. They have the same slope. Parallel lines, they got the same slope. perpendicular lines. Perpendicular lines have slopes that are negative reciprocals. Perpendicular lines have slopes that are negative reciprocals. We're going to say product is -1. Product, that means product of the two slopes. If two lines are perpendicular, their slopes are negative reciprocals of each other. By definition, the negative reciprocal of a number is what you would multiply it by to get a product of -1. If the slope of A is 3, then the slope of a line perpendicular to A would be -1/3. If the slope of line A is 3, then the slope of a line perpendicular to A would be -1/3. Because we said the slopes are negative reciprocals. So if we multiply these two slopes, if we take 3/1, which is the slope of the first line, and we multiply it by -1/3, the product is a positive times a negative, which is a negative. 3 times 1 is 3, and 1 times 3 is 3. And when you simplify -3/3, it becomes -1. So the next part of this section, we're going to be determining whether two lines are parallel, perpendicular, or neither. Parallel, perpendicular, or neither. If you're going to scroll through your phone the whole time, can you at least turn your back to me so I can't see you doing it? Like rotating your chair some. Then it looks like you're taking notes and I can't tell what you're doing. All right, so here we're going to determine whether line AB and line CD are parallel, perpendicular, or neither. Parallel, perpendicular, or neither. And you're given coordinates. Point A is at 1, 1. Point B is at -1, -5. Point C, 3, 2. And point D, 6, 1. So if you're going to determine whether AB and CD are parallel, the first thing you're going to do is you're going to find the slope of each line. So the first line contains points A and B. So we've got an X sub 1 and a Y sub 1, an X sub 2 and a Y sub 2. And then our second line contains points C and D. So that's another X sub 1, Y sub 1, X sub 2, Y sub 2. Now we're going to find the slope of each line. So our M here is equal to Y sub 2, we got a negative 5 minus 1 divided by negative 1 minus 1. And negative 5 minus 1 is negative 6. Negative 1 minus 1 is negative 2. So the slope of our line AB is going to be equal to positive 3. Then we're going to find the slope of the second line. So we've got 1 minus 2 divided by 6 minus 3. 1 minus 2. 1 minus 2, that's negative 1. 6 minus 3, that's 3. The slope of this second line is negative 1/3. Looky there. Those are the same numbers I just used in the example. So what are the lines? Can anybody tell me what's the relationship between the lines? Are they parallel, first of all? They're not parallel. Why aren't they parallel? They don't have the same slope. All right, are they perpendicular? If you take the slope of one line, which is 3 over 1, and you multiply it by the slope of the other line, which is negative 1/3, we just did this, it equals negative 1, doesn't it? If you multiply the slopes and the product is negative 1, what are the lines? They're perpendicular. Good. So we're going to say perpendicular. Remember the symbol for perpendicular, the upside down T? Anybody remember what perpendicular means? What does it mean? Perpendicular, what does it mean? Didn't I say I was going to make you write it a bunch of times yesterday? Or was that the other class? What does perpendicular mean? You could have found it in your phone by now. Can't you just ask Siri or something like that? Siri, what does perpendicular mean?
As an adjective, it means at an angle of 90 degrees to a given line, plane, or surface.
Yes.
Do you want to hear the next one?
Two lines that form a right angle. And what does a right angle mean? 90 degrees. So what does perpendicular mean? Intersects at 90? Perpendicular means intersects at 90. Intersects at 90 degrees. Very, very, very important geometry term. Perpendicular means the two lines intersect at 90 degrees. They form a right angle. The legs of a right triangle. Back over here. The legs intersect at 90 in a right triangle. They're perpendicular to each other. Okay? All right. Okay, so the last type of problem you're going to see today, you are asked to graph the line that contains A which is at negative 3, 0, and is perpendicular to line CD with C at negative 2, negative 3, and D at 2, 0. So you need to graph two lines that are perpendicular to each other. What will the relationship in their slopes be? What will the relationships in the slopes be of the two lines? Graph the line that contains point A and is perpendicular to CD. Perpendicular. The lines are going to be perpendicular to each other. So what will the relationship of the slopes be? Say it again. Okay, let's look back in our notes. See if we've covered that. Oh, there it is. There it is. Perpendicular lines have slopes that are negative reciprocals. Just wrote it down, right? Okay, just wrote it down. So if we go back here and I ask you, what will the relationships of the two slopes be? Does anybody have an answer? They'll be negative reciprocals of each other. Very good. So we got to graph these two lines. So as neatly as I can, I'm going to try to here's our x-axis, our y-axis. Point C is at negative 2, negative 3. So negative 2 and negative 1, 2, 3. Right here, point C. Point D is at 2, 0. So 2 and 0, it's going to be right here. There's point D. And I'm going to run a line through there. All right. This line CD, the slope of line CD, 0 minus negative 3 divided by 2 minus negative 2. What's that slope? We got a 3 over, our slope is 3/4. Our slope is 3/4. Slope of line CD is 3/4. So now we need to graph another line. I'm going to make this line blue. It contains point A, which is at negative 3, 0. So I'm going to go to negative 3 right here, 0, and I'm going to put point A. Can anyone tell me what the slope will be of the line that goes through A that's perpendicular to CD? Another way of asking that is, what is the negative reciprocal of 3/4? Remember reciprocal from Algebra 1? You just flip the fraction, right? Reciprocal of a number is when you flip the fraction. Well, negative reciprocal means flip the fraction and negate it. So what's the negative reciprocal of 3/4? Negative 4/3. So there's a line that goes through point A that has a slope of negative 4/3. All right, so this M is going to be equal to negative 4/3. Which means I rise 4, but I got to run 3 to the left because negative sloped lines go up and to the left. So I'm going to rise 4, 1, 2, 3, 4, and I'm going to run 1, 2, 3 to the left. I can also go down 4 and 3 to the right. And there's my line. All right. Remember, we drew a picture earlier that negative sloped lines go up and to the left. So here's our line through A. That is perpendicular to line CD. These two lines here, they intersect at 90 degrees. So let's try to just clean this up and finish this up here with, let's just do a little table. Let's say slope of a line slope of a parallel, and then slope of a perpendicular. Hopefully this will turn a little bit of a light on. If we have a line and its slope is 2/3, what's the slope of a line parallel to it? If a line has a slope of 2/3, what's the slope of a line parallel to it? Very good, 2/3, because their slopes are the same when they're parallel, right? What's the slope of a line perpendicular to it? Somebody other than negative what? Negative 3/2, right? Or 3/2. See the relationships? Same. Negative reciprocal. So if the slope of a line is negative 3/4, what's the slope of a line parallel to it? Good. What's the slope of a line perpendicular to it? No, look. Negative reciprocal. You got to negate it. It's got to have the opposite sign, okay? Got to have the opposite sign. What if this slope is 3? Let's go. What if this slope is 5? 5. What's the slope of a line parallel to it? 5. What's the slope of a line perpendicular to it? Oh, you guys are geniuses. Geniuses. Now, this is fun now. You ready? We got a slope here of negative 7/8. What's the slope of the line that it's parallel to? Good. And what's the slope of a line perpendicular to both of them? Very good. And now, who sits in front of me right here? This is, you're not Peyton, you're Alyssa. Alyssa, what's your favorite fraction? Your favorite fraction? 7/10. Good. So we have 7/10 over here. 7/10 is perpendicular to a line that has the slope of what? Right? And what's that line parallel to? All right, very good. Very well done. I'm impressed. All right, so now I'm going to give you some practice to do. And your practice for today this is going, let's see. Page 35. Page 35, 1 through 14. 1 through 14. If you're in class, I need you to walk it over and show it to me before you start packing your stuff up and playing on your phone. I need to see the whole assignment complete on a separate piece of paper. There's not enough room to do the work in this workbook. You can use the graphs, though. You can use the graphs on 11 through 14. You e-learners, I just got to trust that you're going to do the whole assignment, and you guys got to check focus for homework. All right, if you're in class, before you put your stuff away or start playing on your phone or any of that other business, I got to see the whole assignment completed. You're going to walk it over to me. You e-learners, at this point, you are excused from the Zoom meeting. If I don't hear or see any questions in the next little bit of time here, then I'm going to go ahead and close this Zoom meeting.